My happy shiny calculus peeps. I miss all of your happy faces. I hope that you are all healthy and maybe going stir crazy. We are at my house. This is a trial run. I'm going to try to do this video for our first section in chapter 6 and send it out, see what you guys think. I don't want to do a bunch and then find out there's something that needs to be changed. So here we go. Chapter 6 is the first chapter, well, the only chapter of integrals, otherwise known as antiderivatives. So you are just undoing everything that you've learned so far. If you'll remember way back when, we learned about how if the position of the maglev is described by some function f of t, then we can measure how fast it's going, its velocity at any time, by taking that rate of change. If I've gone 16 feet at time 2 seconds, and then I've gone 36 feet at time 3 seconds, I can find the average velocity by taking those 2 points, or I can find the instantaneous velocity by finding the derivative. So the question begs, if I know what my speed is, could I figure out what my position is? Yes, we're just going to undo. So if I tell you that my derivative is x squared, if my original function is x squared, then my derivative is 2x. But what if I tell you that my derivative is 2x? You ask yourself, well, if I landed at x, I must have started at x squared. And then I look to say, okay, if I took the derivative of x squared, I would have to multiply it by 2. Do I end up back here where I started? Yes. If only all of them were that easy. Let's go here. So if I have this function, notice it's a capital F. F of x equals 1/3 x cubed minus 2x squared plus x minus 1. I need to show that f is an antiderivative of this f prime. There's the easiest way to go about that, since I'm only asking you to show that this is an antiderivative, is to just take the derivative of this. Three times 1/3 is going to be 1, and I just get x squared. 2 times 2 is 4. So that's the easy part. Technology at my house, sorry. There we go. Can I show that this is an antiderivative of this? Yes, because when I take the derivative of this, I land here. Now, just a moment to think about, what if this had been a 2 or a 3 or a 5 or a 12 or a million? When I took the derivative of this, I would still get this, right? So it could be, as we look at these, that there are numbers in our antiderivative that we don't know about if all we have is this. Just hold that in the back of your mind. So if f of x equals x, g of x equals x plus 2, and h of x equals x plus some constant we don't know, show that f, g, and h are all antiderivatives of the function f defined by f of x equals 1. What we're really saying is, if I start at all 3 of these, do I end up with the derivative of 1? And I do, right? The derivative of this is 1. The derivative of g of x is 1, because the derivative of that 2 is 0. And the derivative of h of x is also 1, no matter what that number is, as long as there's no x attached to it, but we define c as a constant. The point of this is for you to recognize what I was just talking about on the last slide, that it doesn't really matter what this is if it's a constant. My derivative is only going to be based on the terms that have an x in it. So we have this theorem. It just says let g be an antiderivative. So when you hear the word antiderivative or integral, you can think to yourself sort of the original function. Let g be an antiderivative of a function f on some interval that we define. Then every antiderivative f of f on I must be of this form. All that means is that we have some original function and there's a constant on the outside. Now that constant might be 0, so don't let that bother you, but we can always assume that there's some constant on top of our original function that we need to consider. So prove that the function g of x is x squared is an antiderivative of the function f of x, 2x. Sure, because g prime of x is going to be 2x. But also write a general expression for the antiderivatives of f. It could be any sort of x squared plus c, right? That could be x squared plus 2, it could be x squared plus 5, it could be x squared plus 23. I don't know. So we're going to call this an indefinite because we don't know for sure that this is actually g of x. I don't know that it was x squared if all I know that the derivative was 2x. I have to allow for this c to be on the end. So when it says general expression, it's the part that we know we used to get the derivative, plus some constant that could have been stuck on there that we didn't know about. You can see it here. The process of finding all antiderivatives of a function is called antidifferentiation. Remember, we've used differentiation means to find the derivative, or integration. These words are interchangeable. We use this symbol. It's like a long snaky S called an integral sign to indicate that the operation of integration is to be performed on some function f. These are directions. It's just like if we were writing to find the derivative of something. So if you see an integral symbol, that is a set of directions telling you you should integrate this. What I want is the integral of this function. So be careful when you write it and when you don't write it. Here, the integral of f of x is the original function, big F, plus some constant. So a lot of times we will associate the derivative as a little f and the original function as a big F. The indefinite integral of little f of x with respect to x equals, so this part right here at the end, dx means with respect to x, just like when we write the derivative, d over dx. That's the derivative with respect to x. We need this part. It's going to come in later. I really need this dx at the end. It does sort of mean times the derivative of x. We know that the derivative of x with respect to x is always 1. So we can assume here when we're taking the derivative of f of x, if I knew that f of x, well, we'll skip that for the time being. We'll get there. But we are multiplying. It's sort of like the chain rule, right? To find the derivative of something, if this is the derivative, then I multiply by the derivative of what's inside. So make sure you have this d of x written. The function f to be integrated is called the integrand. The constant c is called a constant of integration. The expression dx follows the integrand f of x, reminds us that the operation is performed with respect to x. If the independent variable is t, we write dt instead. Your book calls these dummy variables, just so that you see that. It doesn't matter what they are. So you may see it written plus c or plus k. The integral of 1 dx must be x. The only way I'm going to get a derivative of 1 is if I started with x. And the integral of 2x is x squared plus k. The only way I'm going to get to 2x is if I started with x squared, and I'm just adding some constant because I don't know that there wasn't one. We're going to get to how to solve for those later. You'll need a little bit of information to do that. Here are some rules that I'm going to skip over. These are all the same rules for integration as differentiation. Don't let them fool you. So we want to find each of the following indefinite integrals. You can think about this as the integral of 2x to the 0. Well, what did I need to start at to get a derivative of 0 or an exponent of 0? I must have started with an x to the 1. How did I get the 2? I must have started with a 2 out front. So my integral or antiderivative was 2x because my derivative was 2. In B, remember that pi is not x. This is just some number, 3.14 times 3.14. So I must have also just started with whatever number that was out in front of x if, oh my goodness, if when I took the derivative, I lost my x, then this must have been the constant out front. Find each of the following indefinite integrals. So here we go. I took the derivative of something and I landed at x cubed. So that means I must have started at x to the 4th. Also, remember that when I take my derivative, I'm going to multiply this by 4, and I have to land at 1. So what do I need to put in here in order to be able to multiply by 4 and land at 1? 1/4. 4 times 1/4 is 1. I would lose an exponent here. It will land at 3. For part B, if I landed at x to the 3/2, I must have started at x to the 5/2. Remember that when I take the derivative of this, I'm going to get 5/2 x to the 3/2, but that's not what I have here. What am I going to need to have out here so that when I get the 5/2, it ends up being 1? It would have to be 2/5. You can just double check that. You get 5/2 times 2/5 x to the 3/2. My writing pad does not like my laptop. Sorry, guys. These are going to go 10 over 10, and I'm left with x to the 3/2. This is just a check to make sure that I land back where I started. And I do. So hopefully I'm not going super too fast. You can always pause the video. That's the beauty of this, I hope. Whenever you see something like this, remind yourself that I can just rewrite this. Even if this were a 5 or a 10, the only function of x is in the denominator. So what I'm really looking for is the derivative of x to the negative 3/2. That looks like a 5. With respect to x. Well, if I landed at negative 3/2, I must have started at negative 1/2. Remember, when I take this derivative, I'm going to end up multiplying by -1/2, but I need to end up with 1. So what do I multiply -1/2 by to get 1? -2. If you want to check to make sure you did that right, you say, okay, that would be -1/2 times -2, which would be +1, x to the -3/2, which is the same thing as 1 over x to the 3/2. I hope this is making sense. It's a little bit weird to be sitting in here talking to myself. All right, indefinite integrals again. Oh, I guess I should go back. See, I got caught up in this. So indefinite integrals means that we should have some sort of constant out here, right? I don't actually know that I started with 1/4 x to the 4th. I know that whatever could be added to the end of this is a constant and doesn't matter, but I should at least allow for that. So indefinite integral here, if I landed at 3 for my exponent, I must have started at 4. Again, I'm going to have to multiply this by 4 when I take the derivative. So what do I need to multiply 4 by to get 2? Hopefully you know that's 1/2. And I don't know anything about my original function, so maybe there could have been some number at the end. I will put a C on the end. If you're going along these, I would strongly suggest you feel free to pause before I do the work and see if you can figure it out yourself, and then play and watch what I did. Make sure you get the same thing. Here, if I landed at -2, I must have started at -1. -1 minus 1 is -2. Remember that I need to multiply something by -1 in order to get -3. Must have been 3. So -1 times 3 would be -3. This would drop to a -2, and some constant at the end would not impact what I get for my derivative. All right. I hope you're having fun. I know I am. So, try this one on your own. Pause the video, see if you can come out with this. This is rule 4. All it means is that I can take the derivative of each one of these individually, which makes up the derivative of the whole thing. Or sorry, the integral. Same rules for derivatives. All right, so if I landed at 5, I must have started at 6. I have to multiply by something so that I land at 3. Must have been 1/2. If I landed at 3/2, I must have started at 5/2. Now here, 5/2 times something equals 4. If you don't know that off the top of your head, do some scratch paper. Please don't do this in the middle of your problem. But you do know that 5/2 times, I don't know, we'll call it A, times something equals 4. So if I need to figure out what A is, I multiply both sides by 2/5. Remember that if you are multiplying fractions, that you should write them both as fractions. This is 10 over 10. I get A is 8/5. A is this number that needs to go out front here, because I know that I have to take 5/2 and multiply it by 8/5 to get 4. Here, I know that if I started at, or if I landed at -1/2 for the exponent, I must have started at positive 1/2. What do I need to multiply by 1/2 to get -2? -4, and some value at the end that I don't know about. Now, if we want to go back and just double check, that's going to say check. That's an E. Kind of looks like cheek with an A. Check. So 6 times 1/2 is 3x to the 5th. Here I have 5/2 times 8/5, x to the 3/2, minus 2x to the -1/2. This is going to be 4x to the 3/2. And I do have what I started or what I wanted to land on. Please feel free to do this off on the side of your paper if you don't immediately see what you need to have here. Some of them get complicated like this with fractions. Just write them out and check when you're done. All right, now we got some E's. Find each indefinite integral. I have landed at e to the x, which means I must have also started at e to the x. There is no number in that exponent for me to deal with right now. So the derivative of 2e to the x would still be 2e to the x. Minus, if I landed at 3, I must have started at 4. What do I need to multiply by 4 in order to land at 3? Probably 3/4. Oh, sorry, I don't want to land at 3. I want to land at 1. Come on. So 1/4 plus c. 4 times -1/4 is -1. X to the negative, or x to the third. All right. This is the same as before. You want to think about this as 2x plus 3x to the -1 plus 4x to the -2. We will talk about how to solve for integrals that have a function in both the numerator and the denominator, but right now we're just going to worry about these that we can rewrite. I know that in order to land at 2x, I would have had to have started at x squared. To land at -1, oh, here we go. Remember that when we did derivatives, that the derivative of the natural log of x was 1/x. So that means that if I landed at 1/x, I must have had to start at the natural log of x. Now, a red flag for you to remember that rule is if you're rewriting these, what I just did was say, oh, if I landed at -1, I would have had to start at 0, but that doesn't make any sense. So really what happened was I started at 1/x. Sorry, I started at the natural log of x. 3 times the natural log of x. The derivative of the natural log of x is going to be x to the -1 or 1/x. If I landed at -2, I could have started at -1. What times -1 is a +4? That means that back here my sign is wrong. -1 times -4. And C. We can double check it. Here I'm going to get 2x. Here I'm going to get 3 times the derivative of this thing, which is 1/x. Here I'm going to get a positive 4x to the negative 2. This is just a check to see that this blue part is the derivative of the red part, to make sure that we end up where we wanted. And we did. Okay, we made it, folks. If you were silly business and left your book at school, I'm also going to post the PDF copies of the homework pages on the same place you found this, on the plan book for this day. So you should be able to access those at home. I would very much like to open up like a Zoom question and answer so that you don't have to type all of your answers. If we could meet maybe a couple of times, or I'll be around a couple of times for like half an hour at a time for you to answer or ask any questions so that I can just answer you face to face. That's my goal. I haven't gotten that far. I just wanted to try this out and see what you thought. So I'll send it out. You guys are the best. Thanks for being my guinea pigs. I hope you had a decent spring break, even though we're all trapped at home.